Bum. Oh yeah, we got to do the spinner wheel today. Oh hell yeah! Totally almost forgot about that. Oh look, I'm invisible. Invisible gold. One sec. Here, so you guys can see. There we go. Yes, you can come up and speak. Sorry, why this is. There we go. Yo. Yeah, let me tell everyone that we're doing it. Right, Gilded Gamers.
Finished my cosine homeworks. Now I'm on to
Good. Is a Moog helping you out? Do we need to pay a Moog yet? Do you need to pay a Moog?
I mean, I have to, I guess.
Not yet. It's not Sunday. Wait, it is Sunday. Yeah, pay me up.
Bro, what? It's Monday, dog. What are you talking about? It's not Sunday. Are you on break?
Yeah,
Wait, are you still at
today.
school? Why are you
No.
still at school?
I'm at school. Because Monday and Tuesday is school, and then everything else is a break.
Yeah, see, this is what I thought Thanksgiving break was, but dude, some of the kids I'm working with have this whole week off. I'm like, what?
Yeah. I want a whole week off. Like, bro, just 2 days. Let us be.
Yeah, dude, just what? Yeah, let's look. Okay, so yeah, okay. Who's in our? Where's Teacup? I think Teacup should be here. Where's Teacup?
Bro's lacking, yo.
Where's your Gilded Game Master, dude? What's up?
Is it possible to split the prize?
If you make an agreement with someone, yes, but you have to do that like.
Yeah, because, like, for example, if I win, I don't want the whole 50. Not gonna lie. I'll give it to, like, Jamarcus or someone.
Okay, but it has to be in like gift card amounts that make sense, right? Like I can't give like $7 to someone and like 43 to another.
Yeah.
Like
I
you
only
want
need
to
25.
if you want to split the once you have the gift card, you can do whatever you want with it, right? You know, like I don't care what you do with it, but if you need me to give it to you in like a denomination that makes it easier to give it to someone, yeah, I can do that. I don't care. Like
Alright, thank you.
yeah. Okay. Yeah. All right. For those of you that are watching and like don't know like what's going on, earlier this month, the students voted. We have like this poll. OP needs to do a poll, dude. He hasn't done a poll in a while though. But, anyways, he had started a poll where he asked the students if they wanted to. Where did I put the where's the poll stuff? Where's the Dude, I hate how Discord does this auto collapsing shit now, dude. It's so annoying. Okay, here we go. Poll of the week. Here we go. Yes. Where this was it. He suggested, hey, let's maybe do like a gaming tournament where like, you know, for a month, everyone like votes in on some games and like Gold will give out a prize and something and blah blah blah. And so yeah. Y'all voted for it. Y'all voted for Teacup to be the person running it, who I think did a pretty good job. Like, thank you, Teacup. Teacup gets a $25 gift card just for running the event, which I'm glad. He really stepped up to the plate this time. Teacup absolutely threw. Yeah, exactly. Yeah, we love it.
Not gonna lie.
Also, yeah, he had a lot of help. He had a lot of help from some of you guys because I know Teacup doesn't have Fortnite or some of the games that you guys play. But regardless, it was awesome. And so everyone participated. We had a lot of stuff going on. And at the end of the day, there was a leaderboard. So let's see what the leaderboard was at. Let me see. Let's do GG Common. And then here's the latest. Okay, cool. So in first place, we have Dark Aspect, 35,000 points. Spicy Phoenix with 29,000. Taco Cat with around 27.5. Jamarcus with 27.2. Shifter with 18. And then Ethan coming in there at sixth place with 13,000. Okay, wow. Just barely taking Sam and Shaq off the list. Oh, so close. Anyways, so
we even gave Shaq an extra 3K for no reason.
Oh really? Why'd you guys do that?
we did a little a spinner wheel or something, and we gave Shaq a 3K for no reason.
Okay, whatever. Again, what I wanted this to be. I wanted you guys to like run the tournament. You guys figure out what you guys like about it, you know, because usually I do all of it, and it's a little bit of time, and you know, you guys probably know best what you guys want. So it was cool. It was a cool experiment to see you guys like run your own tournament, and I'm happy to finance it, I guess. So let's see. Okay, so first person we're gonna have is Dark, and the next person we're gonna have is a Moog, and then I'm gonna show you how we're gonna weight these. And then we have Taco Cat, and then we have.
Suggested something for like something like 5K. You get another like raffle or something every 5K you have.
For what? No, so this is how it works. So watch. I'm gonna put the amounts in here. So Dark, you have 35.3. Okay.
Holy shit! There's no
But that's not how it's actually gonna work. Okay. This is called a weight. This is a weighted spinner wheel. So the amount of the thing you have is dependent on how many points you have, and also dependent on how many other points everyone else has. So Taco Cat at 27.2.
There's no way.
Wait, we're not there
There's
yet.
no way I'll win this.
Well, we don't know. I mean, again, it's a game. 27. Wait. Phoenix is at Taco Cat. Oh, it's 27.6. Okay, 27.6. Jamarcus was at 27.2. Shifter was at 18.5. And then Ethan was at 13.1.
But imagine me having that. I would have the
Okay,
smallest chance.
so this is how it works. Yeah, but this is how it works. This is why it's a weighted spinner, okay? So, because I want it, some person always ends up, like, getting pretty far ahead, and I don't ever want to discourage everyone else from, like, still trying to participate, so I put, like, some little elements of, like, luck into it. So, this looks good. I feel like I should move Dark around just to, like, try and... Like, okay, you guys can't say that this is rigged, right? Because I'm moving Dark around in, like, just random places, right? Okay? So, whatever happens, happens. I know he somehow always wins these things, but I've tried to introduce so much randomness to this, okay?
No, please, I need to win.
Okay. All right, so we're going to do the spinner for the winner of the
Wait,
Gilded Gamers tournament. What's up, Ethan?
Can I say a few last words real quick?
Yeah, say a couple last words. What's up? What do you want to say, Ethan? Before we spin the wheel.
There's only one winner. There's only one winner, right?
There's only one winner of the big prize, but I think Teacup said we're gonna give bond coins to everyone else. So, yeah,
Oh, nice.
yeah. So,
Bonkers is useless for me.
well, you just need to do some of the brilliant stuff, Nick. Come on, dog. You don't have to do all of it.
I did like half of it, but there's so much.
All right, whatever. We'll talk. Anyways, so yeah, so the main prize is a $50 gift card to anything kind of video game related. Please don't ask me for like an OnlyFans gift card.
Please, come on.
Hey, you gave me the idea. You gave me the idea.
For that, bro.
I don't even know, did-
OnlyFans.
Do they do gift cards for OnlyFans? That's like kind of fucked
Yo, I
up,
was
dude.
about
What?
to ask-
Do they- Oh, what's up, Teacup? Here, you want to say some things to your contestants before I roll the wheel?
Slacker.
Because you absolutely threw. I just want to say, yeah, you absolutely threw on making this.
Yeah, dude. Moke says you threw Teacup, dude.
Yeah, I did. a little bit.
Yeah, I want to ask you something.
Sorry, what's
Yes.
What is an OnlyFans? I
No, it's
never
okay.
heard of that.
No, don't worry about it. No, we're not going there. We're not going there.
Go
You
come off
guys
the stage.
heard
He doesn't need to know about it.
All right, no.
No.
Spinning the wheel. Here we go. Spinning the wheel. Spinning the wheel. Who's gonna get it? No.
You never done
Stay
that.
innocent, please, dude. Okay. Wow, goes the monkey.
Yeah.
Wow, almost a shifter, dude. Almost, dude. Congratulations, monkey. Good job, dude. Taco Cat won. All right. Teacup, what all the other contestants get for the top 10 or something? Rigged? No, it's not rigged because at least fucking Nick didn't win it again.
Yeah, I would have gave a little bit to a Mo.
Yeah, I would have been. I would be so like, what the hell? Teacup, do you have a mic? Is your mic working?
Oh, hi.
Hi. Yeah. So, yeah, what do the other players get in
I
the
sent it
tournament?
I sent it in the DM.
You sent it in my DMs?
Yes.
Oh, sorry. I threw the tourney. My great aunt died. My cousin fractured his skull. Dude, no. Through the tourney means you did a good job. Not that you not that you threw it like badly. Oh, I assume that's what you mean. Is that what you mean, Amog? Did you mean he threw it like it was great or it was bad?
Very bad. I'm joking.
No comment. No comment.
Oh my god, y'all too
You
funny.
mean it was bad?
I think it was great.
You was man.
Anyways, here we go. Here's what the top 3 get: 5 bond coins. Congratulations, top 3. 4 through 6 get 3, and then 7 through 10 get 2. Awesome.
Only 5.
5's a lot. It's like $5 worth, dude. But, oh, okay.
Yeah. I need
Monk-
100.
Monkey gets +5 too. Maybe we won't give 5 to Monkey because Monkey did technically win $50. But okay. Anyways, I appreciate it. It was a lot of fun. I may do I may do a little contest afterwards for more like bond coins, or maybe we'll do it for an entry. Here's what I'll do. I'll do another like random spinner wheel giveaway. But you have to make like an actual good suggestion of what you would want to see in the next tournament. Yeah, it's not bond coins, Tuhi. That's tournament points. I'm sorry, the tourney sucked. I thought the tourney was great, Teacup. It got really competitive. Like, look at the scoreboard. It was very close between Jamarcus and... So, this is the sign of a good tournament. The sign of a good tournament is when there's a lot of competition and, like, people are very close. Like, you have Jamarcus and Monkey, like, within 300 points of each other, which is awesome. I know that Nick kind of got ahead, which is okay. I mean, Nick participated in a lot of the things, and he did well in a lot of the things. That's why he has the most points. But everyone else... Teacup, you designed this tournament pretty well because everyone was pretty close to each other. Like, you had blocks, definitely, of like, people, which is good. Usually, if it's a bad tournament, usually someone has everything and no one else fucking cares. Which, you don't want that. Yeah. So, yeah, good job, Teacup. I'm proud of you. All right. Cool. All right, let's start the stream. Welcome, everyone, to Office Hours. My name is Dr. Scroll. This is Actual Education, a stream that helps you out with math, homework, science, homework, all that fun stuff. It's Thanksgiving week. Some people are still in school. Some people are not in school. I'm still teaching regardless. I think I taught like 6 kids yesterday because everyone's got exams either like before Thanksgiving break or after the break. So I've been busy for sure. But I'm here to help you guys as well. No. Can you guys chill on the OnlyFans stuff, please? Oh my god. Okay. Let me find what we have here for pictures. Ethan. Oh, you haven't posted anything yet. Ethan, are you here?
Yeah, I'm just playing chess right now. Hold on, but I really can't find a question.
Oh no, play chess. Don't worry. You're in your tournament? Are you in your tournament?
Yeah, no, yeah, I'm just practicing before.
Okay.
But yes, I still need help.
Okay. You want to just ping me when you're done with your game, and then I can help you? Is that cool?
I think I could play while I talk.
No, it's okay. Isn't it a timed game? Isn't it like a blitz game or something?
Yes, it is. How do you know it's a blitz game here?
Well, because you showed me a screenshot. You were playing blitz, weren't you?
What kind of, yeah.
Yeah. Also, like, chess games without timers, like, become really kind of, like, boring, honestly, because you just think forever about, like, what the correct move is.
Mm-hmm.
Yeah. Yeah, let me know when you're done with the game. I'll help you out. I'm sorry you have to go to a teacup. I'm sorry that you have to go to a teacup. I'm sorry, teacup, that you have to go to a funeral. Funerals are no fun. Although they are kind of good opportunities to at least, like, meet up with family again, which I think is great. So there's always a golden lining to things, you know? They say it's either weddings or funerals that brings all the family together. And, like, there's different phases to that. Like, usually people start, like, you know, passing on to the next life, and then everyone starts getting married. So, and then the cycle repeats. She lived to 97. Yeah, wow. Yeah, bro, I'll be real happy if I make it to 97. That's insane, dude. Almost 100 years? I mean, I've had a pretty good time with the first 33. I can't imagine, like, going to 100. That's a lot. Yeah. Lamau. Dun, dun, dun. So we got a screenshot. Yes! Teacup's got something. What's up, Teacup? I like this. Are we doing Hooke's Law? Blah, 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 blah. Page 360 of the PDF. All right, let's look at it. Ugh. Calculus. Is there a new Fortnite out? Is there? What season are we on right now? Does anyone know? I can't keep up with all this stuff. 360. Chapter 4, Season 5. Oh, okay. Because, what is it? They're doing, like, the OG run or something for the next, like... Yeah, it's still coming back for what? The next couple weeks? Yeah, the Battle Pass is different and everything. I know that, yeah. End of November. Oh, okay. Well, that's, like, next week, then. Okay, cool. December... Are they doing an event for it, too, He? Do you know if they're going to do an event? Yeah. I usually do like a live stream for like if they have like a whole, you know, event thing or whatnot, and then there's like a whatever, I'll usually live stream it and then I'll give out like V-Bucks at the end or something. I think this is the shortest season. Yeah. Well, because it's a throwback season, right? Yeah. That's cool. Cuz I never, you know, I only got into Fortnite probably I want to say like a year and a half ago. So I don't know any of the newer stuff that you guys talk about when you're like, oh, remember this gun? I'm like, I wasn't there for that. I forget what, I think I came in around like season, I don't know. Does anybody know when I first started playing Fortnite? Ooh, Calculus. Yes. Yes, Penn Center. I was about to say Chardonnay. How Chardonnay is so buttery. Isn't that the most buttery wine? Chardonnay on a Sunday. Did you have like a Friendsgiving event you were at or something? That's the only I guess, yeah, because when I look at like all my Instagram stories, like everyone did Friendsgiving this weekend. So Friendsgiving is where, so usually Thanksgiving you do with your family or, you know, yeah, usually family and whatnot. And then if you have friends that also want to kind of do it, you tend to do it the weekend before. I'm probably going to do it the day of because I'm not going to go see my family for Thanksgiving because it's kind of far away. Plus, most of my family works in like the medical field, so they either only get Thanksgiving off or they get Christmas off. So they have to pick one. So most of my family's working on Thanksgiving anyways. So we pick Christmas and meet up for Christmas. Let's never talk about Chardonnay again. Uh-oh. Yeah. I've been there. Where I swear off like one type of alcohol because I had a bad time with it. And then it just comes back to me like, you know, a couple months later. I can tell you how many times I've sworn off tequila. And then... Yeah, nope. Let's see. We've done these sort of derivatives. What do I want to do with you, Teacup? What do I want to do? Ooh. Find the dimensions of the cone. Ooh, I like these. These are good. Aha! Yeah, that's a good one, Teacup. Let's do this one. Yeah. The butter went to my brain and I was smooth brained all morning. Yeah, the trick for that.
I just finished the game.
Oh, nice. Okay, cool. Let me teach Teacup. Let me teach this to Teacup, and then I'll help you out. Is that cool?
I did win the game as well.
Oh, nice, dude.
We did this already.
Did we? No,
We did.
we did. Here, I'll show you. I know what we did. I know what you're talking about. We did. Well, we did this one. You talking about this one?
No, we did one with a triangle.
Yeah, let's see. I think we did a related rates with the triangle. Is what we did. Okay, well here's a good thing, Teacup. If we did it already, you should already be able to do it. Right? Do you know how to do this question?
No.
See? Okay. So, you know, that's a good reason to do it again. If we have done it again. I don't think we've done it again, but I'm curious. Yeah, Penn Center, the trick to that, at least towards the end of the night, is like every time you have like a glass of wine, make sure you drink like a glass of water as well. Like switch it off every once in a while. And then when you go to bed, like I eat like 4 Advils or something. And then have like a coffee ready in the morning. That's if I have to use my brain the next morning. I've had some rough times where I gotta like teach, and I'm just like, ugh, no. Okay, so reset. We have a right circular cone that has this volume, teacup, and the surface area is equal to this, okay? And it says find the dimensions of the cone that has a surface area of 1 and the most volume, the maximum volume.
So trying to find when it's pretty much at its peak amount. So
Good.
at the top.
Good. When what is at the top? What's the peak?
And we know that the radius is. We don't know what the radius is.
No, we just know the surface area is 1. This is the reason why this is a cool type of question is because think about this as like an ice cream cone, right? So when you make an ice cream cone, well, I don't. You probably haven't actually like made a cone before, but you know, like usually, like you take like a piece of paper, right, and you like fold it around, right?
Yeah.
Yeah. So there's always like a certain amount of like area of material that you need to use, right? And so the question can be here, okay, so when I'm making my ice cream cone, and let's say I have a certain amount of like paper, a certain amount of area, like how wide, you know, do I want to make my ice cream cone, or like how narrow do I want to make my ice cream cone so that it can fit the most amount of ice cream? That's why this is called an optimization question. Do you know what optimization means?
Make it better and faster.
Good, make it better, make it the best, right? So you can think of like two extreme cases, right? So if for instance I tried to make my cone like really like shallow, like kind of like this, it probably wouldn't hold very much ice cream. We're yapping about ice cream, Amog, right? But the other extreme, right, teacup, is that I could make my ice cream cone like super narrow, like this, right? And it probably wouldn't hold the most amount of ice cream. So
Yeah.
there is some in between here where the amount of ice cream we can hold is the best. That's how an optimization works. Okay, good. Okay, so what we always want to do when we're doing optimization problems is figure out what are we trying to optimize, right? So, which is what we're trying to get the max or trying to get the min for, right?
So we want the minimum it can hold and the max it can hold.
No, we want the max. Because look here, it says find the
Surface area
dimensions,
1.
surface area 1, and the maximum volume, right? Pen Center. Oh, man. Yeah, here we go. Dude, being an actual teacher is kind of a nightmare sometimes with all the evaluations you have to do, all the hours and everything. And I know my dad did it. And like you have to take these tests and stuff. And then you got to like plan lessons. I don't know. Seems like a lot of work. And then like some teachers just like suck at teaching. But okay, teacup, we're trying to maximize the volume, right? So this is what we're trying to maximize. V is equal to pi over 3 R squared H. It is very rewarding. Yeah, for sure. It really is. No, I get you that. Yeah. I mean, that's what I do here, honestly. And why I teach students more individually. And that's like super rewarding because I don't know, I feel like I get to like really know the students like one-on-one pretty well. And it's easier for me to like help them one-on-one. I don't know if I could teach like a class of 30 kids. I think I'd get like too caught up in not everyone's getting this. How do I move forward? You know, I kind of want to always make sure, especially when I'm teaching one-on-one, I'm like, do you get this? Does this make sense? Because if it doesn't, like, we're going to stop. Like, yeah. Okay. Teacup. This is the volume of a cone, right? What does this volume depend on? Like, what are the variables you get to change?
Depends on the height.
It depends on the height and the radius. Okay.
Yeah, because the bigger the radius, the more volume it can fit, and the higher it is, it gets a bigger radius as the higher it goes.
Exactly. But also you can see, right, that as you increase these, you also, change the surface area, right? So in an optimization problem, you want there to only be one dial that you're turning to try to optimize, okay? So in this case, I have 2 dials, right? I have like the radius dial, and then I have, the height dial as well, right? Do you see that? Teacup. But I want there to just be one dial that I turn. Okay? So what I want to do is I want to try to relate one of these variables in terms of the other variable. Okay, Teacup?
Yeah.
And the way to do that is with this other equation where they say that the surface area, which is equal to 1, right, is equal to pi r square root of r squared plus h squared. Okay? So we want to try to come up with an equation here, right? Because you see how we have r's and h's, right? R's and h's. We want an equation here such that we have some relationship for between r and h, and we can make this simpler. Okay? So, let's see how we want to do this. So I think I want to put this pi underneath here. Wow, thank you! Thank you, Penn Center. More subscriptions. We love them. Are you streaming over the break, Penn Center? I always wonder whether like I should stream over Thanksgiving break. I think I might take Friday off or something at least, but yes, you will be. Okay, cool. Cool. Yeah, maybe I'll do. Yeah. Okay, so here I'm gonna divide pi on both sides. I'm gonna have this like 1 over pi, and then this is equal to what this is r square root of r squared plus h squared. Oh, I forget. Yeah, you're from Canada, Penn Center, right? That's right. We have so many Canadians here. When does the next tourney start? We'll think about it. Yeah, Jamarcus. We can start another
I think
tournament.
next one's the winter tourney.
Yeah, we should do the winter tourney. I need to get better at like. I had a friend come over actually and really like brainstorm some ideas to get some more funding for like big prizes. Yeah.
I know. I'm probably not gonna participate in the winter tourney.
Why not? You do good in the tournaments.
I'm not gonna do good on it. I don't really feel like doing it.
Okay. Well, what if the prize is a laptop?
Well, if the prize is a laptop, I might as well try.
Yeah, it's all about finding the right motivation. That's what it is.
I'm not gonna win, but I'll try.
Good. Yeah, well, no. Always say you're going to win. Dude, manifest it, man. You know how many times, like, Nick says he's going to win and then he wins? That's because he says he's going to win. It's the first step to winning. Okay. So what I'm going to do here, Teacup, I'm trying to get, like, R equals something or H equals something. But this square root is, like, annoying. What do we do to get rid of square roots?
Get rid of square root, we spare it.
Square both sides. So that's 1 over pi squared is equal to r squared, and then this is r squared plus h squared. Because what I did is I squared both sides. That's what I did. Okay, awesome. So I think I want to do this in terms of... I'm trying to think how I want to do this. Because I could multiply this through, but then that starts making things like messy again. I think I'm going to divide by r squared here on both sides. So that's going to be 1 over pi squared, r squared, is equal to r squared plus h squared. And then I'm going to subtract h squared. So I'm going to get that r squared is equal to 1 over pi squared r squared minus h squared. Oh, wait, no. No. I want to subtract r squared. That's what I want to do. Because you want, Teacup, you want all of one variable to be on one side, and you want all of the other variable to be on the other side. So I'm going to get rid of this one, is what I'm going to do. So yeah, that's h squared is equal to 1 over pi squared r squared minus r squared. Hello, kittens. Sup flashbacks to Saturday. Jordan saw me and said, sup, dude. Meow. Okay, cool. So this bundle of joy is going to come over here. Man, this kind of sucks. Wow, this is actually kind of a hard one, I think. Yeah, that's pretty annoying. I'm trying to think there would be an easier way to do this now because the R's going to distribute through. Fuck. Ew. Okay, fine. Okay. So I get V is equal to 4/3 wait, no, pi over 3, sorry. Pi over 3, r squared, and then instead of h, we're gonna do this. We're gonna say that if this is true, right, then h is equal to the square root of all this stuff. So then this is gonna be, oh man, what is that? 1 over pi squared r squared minus r squared? Yeah, minus r squared. All right, don't forget r squared. Sup, dude? That's so fun. Okay. And then this is all to the 1/2. Okay. Man, this is ugly. It's a really ugly equation. Okay. I think I want to bring this inside now. Inside the square root. Do you know how to bring things inside square roots?
No.
Okay. So let's say I have x and it's outside of like x minus 2. And I want to put this inside the square root. How do you know how to like multiply like 2 square roots together?
To multiply 2 square roots?
Yeah, let's say we had like the square root of a times the square root of b. What would that be equal to? Gotta remember our root rules, right?
Would it just be... Hold on. What? I have some minor deficiencies in my knowledge.
Okay, this is equal to the square root of a times b. So, if I have an x on the outside and I'm trying to put it inside of the square root, another way to write x would be the same thing as the square root of x squared. Do you see that, teacup?
The square root of x. What?
Squared, right? That's the same thing as
okay.
x, right?
Yeah.
Now I have 2 square
Cross
roots,
it out.
right? If I have 2 square roots, I can put them under the same house. Mom and dad love each other again.
That's dope.
And so what this is all going to become, right, is what? What happens when, like, now these two things multiply by each other?
So when we have... So we have a times... Wait, we're doing x squared or ab?
The x squared one.
Okay, so we have... So it would just be the square root of x. Would it just be the square root of 2x minus 2?
No.
Be x squared times x minus 2.
X squared times x, right? So this is x to the third. Yeah, right, pen center. They're under the same roof again. Isn't this so nice? Minus 2x squared, right?
My math ain't mathing.
That's okay. Most marriages in America aren't either. So, you know, everything's in a separate house. Cool. All right. So, if I want to put this inside of this, right? This is a square root, right? Well, let me move this over. This is a square root here, right? How can I write this thing as a square root of something?
So we have that time. So it'd just be all of that times pi over 3 all squared times 1/2, you know?
No. Remember what happened up here, teacup, right? If I had something outside of a square root and I wanted to put it back inside the house, remember how like I had to write it as the square root of something?
Okay, so it would be the... So we have the... Wait, hold on. Pi squared over 3 squared all squared.
No, not pi squared over 3 squared. This is fine. This is the only thing I need to put in the house, right? The r.
Yes.
Okay. What am I going to do with it?
Okay, well now that we have it, we might as well...
Mm-hmm.
Okay, so it's all squared, so does it go with the all... So we do times all squared.
No. Look what happened here, teacup. X,
Yeah,
I wrote
the
as
x turns x squared.
the square root of x squared, right? So if I have x to the second over x minus 2,
Oh, would it be x to the third?
close. X to the... X to the fourth.
Yeah, I don't know.
X to the fourth.
Oh,
X to the
How
fourth.
did it get to x to the fourth?
Okay, because a square root is the same. So the square root of this is the same thing as something to the 1/2. Okay.
Oh.
So look, if it's the square root of x to the 4th, that's the same thing as x to the 4th to the 1/2. When you have power to a power, you multiply the powers. So this becomes x squared. Square roots always cut the powers in half, is what we say. Okay? Yeah, Noise, you are correct, actually. The square root of x squared is technically the absolute value of x. Well, technically. Okay, so Teacup, what is this going to become? The square root of what? Teacup.
Hello, sorry, my internet cut out.
It's okay.
So we have. So it would be the square root of. So the all square turns to all 4, right?
Yes.
So it's
R to
all
the fourth.
that and then all 4.
Good. And then it's all this shit, right? So now, the cool thing here is that now I have 2 square roots. So, mom and dad go to counseling, and now they get to be under the same house.
What the voice ass shit?
So here, this is what happens. Yay. See? All happy. Okay. Now I can kind of distribute this out. Do you see how this thing can start, like, being...
Yeah.
Okay, what does that become?
Oh shit.
Oh, shit. Not again.
I need to figure out how to do math now. Okay, so
I know.
all
know.
4, so we have 1 over pi squared. Oh Jesus Christ.
It's okay. So you're right. This is R4 over pi squared, R squared, excuse me, minus. And then what happens when this one multiplies by this one?
All 4 times all squared. Yeah, all 4 all squared. No, that's all 6.
R6. Good. Okay. Cool. Good. Okay. And then we can simplify this a little bit, right? What happens when I have R to the 4th over R squared?
All to the 4th over all squared.
Mm-hmm. How's it simplify?
That's all to the squared.
Good. So this just becomes R squared over pi squared. Okay. Awesome. This looks a little bit nicer because then I can write this as like this to the 1/2. Okay. Now, in order to do an optimization problem, so do you see how this is like probably some wacky jacky like type of graph or something, right? V is equal to, I don't know what the fuck this like looks like. It's probably really weird.
It's like okay.
This has a maximum somewhere. Like there is a maximum value for this. Like this curve may look like something like this, but it has a peak somewhere.
Yeah. So we have
What do we know about things when there's a peak?
There's also a minimum.
Well, no. What happens at a peak in terms of like derivatives and stuff?
Was that when it was 0? No, that's not when it's 0.
Good. The derivative is 0.
Oh.
Things will be peaks or minimums when the derivative is 0. So, I need to take the derivative of this thing and then set it equal to 0. Okay? This becomes kind of a tricky derivative to do. Okay? Right? Because do you know what the derivative of this whole thing is to the 1/2?
No.
No. But what if I were to replace this thing, right, with just like a box? Like here, mega box. Do you know what the derivative of something to the 1/2 is? It's like this.
The -1/2.
Good. Yes. So, right, this comes down, so it becomes 1/2 times whatever was in the box, right, to the -1/2, okay? And then the price you have to pay for doing this trick is that we also have to take the derivative of what was inside the box.
He's not as detailed as the.
Okay. So, this is the derivative then of r squared over pi squared.
I felt my tent.
It's okay. Okay, so this is going to be like whatever. Cool.
Oh wait, so we have all squared. No, we have all squared over all pi squared minus all 6,
Yeah.
all to the negative 1/2. We're taking the derivative of that, right?
No, we did that.
Yeah,
So we already did the derivative because we took this, the 1/2, we dropped the power, but then we have to take the derivative of what was inside. That's what this part is.
To the 1/2, right? No, just
No. There's no 1/2 now. It's just the 1/2 of what we have.
so it's just okay. So we got 2 to the first over.
Good. Good.
So 2 to the first over. That's just pi 2, right? It's not
Pi 2.
squared.
Good.
And then we have minus 6 all to the 5th.
Good. 6 r to the 5th.
So I had to
Okay.
help my parents or something.
No, it's okay, dude. Okay, so this goes right here. Okay, cool. So my final expression is honestly like kind of messy.
I think we should burn it.
I know, it's going to be this. So it's going to be 2r over pi squared minus 6r to the 5th, all divided by, because this is a negative 1/2, so this is like the square root on the bottom of r squared over pi squared minus r to the 6th, okay? And I need this whole thing to equal 0. Okay?
Do we have to like solve now?
Yeah, so how do I usually make something equal to 0? Like if I have a fraction, right, going on here, right? How do I make this thing equal to 0? Do I need the top to be 0? Do I need the bottom to be 0?
Top. No,
Top.
not top.
Yeah, top. Don't make the bottom 0. Dividing by 0 is a really bad idea.
I love the underline.
Don't do it. Just don't do it. So I'm going to set this thing equal to 0. I'm going to say that 2r over pi squared is equal minus 6r to the 5th is equal to 0.
Equal to 0.
Good. So, this doesn't look too bad to solve, right? How do you think we do this?
Alright, so let's get rid of that. Well, do we want to get rid of the fraction first? What do you think?
I think we want to like put this thing over here first.
Oh yeah, let's do plus 6 all to the 5th.
Right, so I was just going to make this an equal sign like that, right?
2r over pi squared equals 6 all to the 5th.
Yeah, it's a lot easier to work with, right?
Yeah, no, now yeah, what do we do?
Now we can just divide by r. Divide by r.
Divide by r.
Right, this goes away. Goodbye. This becomes
2
r to the
over
4th.
pi- 2 over pi squared equals 6 all to the 4.
Good. So then, what do you do next?
Do we divide? No, we don't divide by. Ooh, what do we do with that fraction? I mean, that.
No, this is okay. This can chill. Again, eye on the prize, dude. You're trying to get this thing by itself.
Can we move the? Oh, wait. Are we trying to get r on itself or 6 or 4 to itself?
We're trying to get r by itself.
Okay, so let's just do divide by 6.
Perfect.
Okay, cool. 6 goes away. We're left with this. Last step.
Great. Can we do what's it called?
Fourth root.
Quad roots.
Quad roots.
Nice.
Quad roots. Yes, good. Okay. So, my final answer is r is equal to 2 over 6 pi squared all to the 1/4. And you're done. Yeah, honestly, that question was kind of a mess. How is that like just like the number, dude? How is this question just number 16 like in this book? What? I feel like that was excessive. Like I don't know why we had to do that much work for this, but okay. Yeah. Oh, and I don't have the solution for this one, do I? I don't think so. Shaq, your mic keeps like coming in and out. What's up, dog? You good? Ow, Jesus. Oh my God, that hurts. No, Shaq. No. Okay, no, my God. Oh, Shaq, what are you doing with your mic, dog? I don't know. I muted him. It's okay. Shaq, you can tell me when you fix it. Okay. Cool. Unmute you, bro. Okay. Is your mic fixed? No warnings or nothing? I told you, dog. Dude, that's super fucking piercing. I told you not to do it.
I'm not doing that shit on purpose, bro.
I know. I know. But don't do it during the stream, dude, because it's loud. Because there's 8 other people watching this on Twitch.
How the fuck do I control that?
I know. It's okay.
Yo,
all right.
How do I control that, bro? Like,
what do you mean? You didn't do that on purpose? That just happened?
no.
Oh, okay.
Yeah, it just happened.
Oh, that's weird. Okay. Nick's like, nar.
I'm over here playing 1v1s. Like,
Oh, okay.
I
You're
don't
good.
know.
You're good. You're good, dude. You're
Then
good.
you said my shit. My shit unmuted it. So
It's all good.
I'm a
Jamarcus says
liar.
the one problem I had with
Whatever,
this
do
was
what?
there were a lot of games I couldn't play. Others were times where I wasn't free. Yeah, Jamarcus, when I do like winter games and whatnot, it's more than just video games. This one was just strictly really a video game tournament because that's what you guys wanted to do. That's what was voted on. But when I host the tournaments and whatnot, it's not just strictly video games. I make sure that like even if you don't play video games, you can still be competitive. And I think that's what happened with I think didn't Obama play like 0 of the games, but he won the Oculus. Like, I wonder if he still uses that thing. Wait, what happened? I was ordering sushi. What sushi did you get? I like sushi. Can you get good sushi in Canada? I wonder about that. You know, maybe. I guess you guys are close to Japan-ish. So what else is it? So usually, so Jamarcus, usually I have like math challenges that I do, and then we also allow you to buy points during the stream using channel points and stuff. And then we do all sorts of things. There's all sorts of cool little random things that I do that aren't just, you know, do you play Fortnite? Noise is going to get all the math challenges. Well, he might, but you know. But also, I think you're able to attend more streams than he is, you know. I also did a thing where like if you asked a question, you got points. So that was another one. Deep fried octopus. Ooh, yeah, dude. I love octopus. They're such smart creatures, unfortunately, but they do taste really good. So I kind of feel half bad. Yeah. All right, Ethan, you got a math test coming up. Let me help you out, dude. What's going on? What's your math test over, Ethan?
Or what we discussed on Friday and bearings of an angle.
Yo, goat, I might hit Unreal, yo.
I have no clue what Unreal is.
Did I get kicked out?
No, you're still here. I hear you, dude. Sorry, I was getting
I
one.
lowered your thing, but I think I lowered you too much.
It's okay. It's okay.
I'm a mute, so I don't disturb y'all.
Okay, I appreciate that. All right, Ethan. Yeah, you need help with bearings and fried calamari plus lemon dressing pepper. Yeah, dude. Oh, I love calamari. There's a joke. Not a joke. Sorry, there's a funny story of me in Vegas. I was like turnt as anything, and we went to Margaritaville, and I just kept asking the waitress if we could order calamari, and she kept saying we don't have it. I apparently wasn't taking no for an answer, so I kept asking for more calamari. It's my default appetizer. If I go to a restaurant, I'm like, "Do you got calamari?" I will eat it. Okay. Ethan you have bearings. Is that what it is? So okay, here's a good one.
Yeah.
Okay, so let's say we have 2 vectors. I'm going to say that... wait, is your math test also over law of sines and law of cosines?
Well, not really like in general, like asking you to do something and then use a law of sine and cosine. It's just with that triangle thing, but that's it. What about the bearings of an angle?
Okay. Yeah, let's do bearings of an angle. Okay. Let's say an airplane... sorry. Is traveling at, let's say, 30 degrees east of north. Is this what they give you when they give you bearings? Do they do this? Do they say like east of north or north of east? Bearings. It is related to navigation. Murgle Schmurgle, you are correct. So how do they give you bearings, Ethan? Do they write this? Do they say 30 degrees northeast? Is that what they say?
But they do write 30 degrees at something of in a unit, like how long they've been going to and stuff.
Oh yeah. Okay. Yeah. Okay. We'll just say 30 degrees. I'm just gonna say 30 degrees, and then we'll get the bearing. It's also called like the heading. I think is technically what's called heading, right? Heading. Okay. And let's say at 30 degrees for 200 miles. Okay. It then heads west. And here, let's make this actually, I'm going to say this is 500. Heads west for 400 miles. And then the question we're going to ask is, what is its final bearing? I guess, right? Final bearing.
Okay.
Bearing. Ooh, yeah, dude. I'm an Eagle Scout. Murgle Schmurgle. I love Boy Scouts. Boy Scouts is great. Yes, knowing how to read a compass is also very good. It also like help you out of dangerous situations when you get lost. Okay. All right, so let's try to draw this out, Ethan. Okay, so I have an airplane, right, that's traveling at 30 degrees for 500 miles, okay? So let's say I have, this is my, like, coordinate system, right? Ooh, also an eagle, that's cool. How would I draw this on the graph?
Also, I would need a protractor.
Okay, so let's get you a protractor.
Yeah, basically, a 30 degrees is like within the northeast, but then yeah, I'll need a protractor to be accurate.
Yeah, so I have a protractor here, right? So we can see that's kind of like this, right? We're just gonna say it's this much. Well, here, let me get a different. Damn, Schmurgle's like having me like remember like my childhood, dude. I remember OA. I think I was a part of the OA, but I think there were levels within OA. I think I just did like the basic one, which was you had to like survive by yourself for a night, right? Like in the middle of the wilderness. I did that one. But then I think there were even more ones you could do. It was pretty cool. Is any of you students in Boy Scouts? Do any of you guys do Boy Scouts? Is that like not cool with you kids anymore or something? Or do you even have them? Or did like they get such a bad rap for like touching boys and shit? I don't know. Like what happened? Okay, so that's like 30 degrees, Ethan. You see that? That's pretty close to 30, right?
Yeah.
Okay. So we're going to call that 30 degrees. And we're going to say that travels for 500 miles, okay? All right.
Okay. After that,
What's up?
the chess tournament is starting in 6 minutes.
Okay, well, let's do this really quick. Okay, so we'll get you ready. All right?
Yeah, please.
It's okay. Okay, and then it goes west. Ethan, west is directly this way, okay? For 400.
Yeah.
Does that make sense? West, 30 degrees, okay? So we're going to call this vector B. I'm going to call this vector A. So what you always want to do, Ethan, is you always want to like add this one to this one by going from here and then to here, right?
Yeah.
So the first thing I need to do is I need to break up A into components, okay? Let's break it up into X components and Y components. Do you remember how to break this one into X and Y?
No, I don't.
Okay. This is a triangle, Ethan, where this is going to be the X component and this is going to be the Y component.
All right. How many
Okay.
times will it travel in the X direction and Y direction?
Good. How do you think we get the X direction from this, right? It's a right
Okay, I
triangle.
think isn't hold on. Is that gonna be a 400 for the X direction since we already have like vector?
No, we're looking at vector A. You're right for vector B. You are right, Ethan, here, right? For vector B, you are right that X in this case is going to be negative 400, and then Y is going to be 0.
Yeah, it's traveling to the left.
Good.
Yeah.
In order to get this one, Ethan, to get in the X direction, this is going to be 500 cosine of 30 degrees. And then this is going to be 500
Okay,
sine of
well.
30 degrees. We're just doing sine and cosine, right?
That is same, right?
What's up?
Which is the same number, right?
No, that's cosine and sine of 45. 30 is not, okay? Cosine of 30 is the square root of 3 over 2. So this is going to be 500 square root of 3 over 2. Sine of 30 degrees is 1/2. So this is going to be equal to 250, okay?
Never mind. They're not the same.
They're not the same. So then what you're going to do is you're going to add these all up to get what's called like the resultant vector, Ethan. That's this one. This is called like C.
Yeah, I learned that in physics.
Okay, good.
remember that in physics.
So that's 500 square root of 3 over 2 minus 400. And then this one is going to be equal to 250. So this is the X,
All right.
Y, 250. Okay. So you can then plot what this looks like, Ethan. Right? So, well, first I got to figure out what the what is it? The square root of 500 square root of 3 over 200 is. So here, let me get my calculator out.
Let's go. You better hurry up. It's gonna start in like 2 minutes now.
I got you. Got you, dude. Okay, calculator. There you are. So, 500 square root of 3, that divided by 2, minus 400. So that's 33. So the x direction, it goes 33. Okay.
What about the y direction then?
It goes 250.
Dang, okay.
See how that's going to be a very, very, like, big resultant vector? So then to get the bearing, right, we need this angle, which this is where you're going to use tangent. Or you're going to say, so the tangent of theta, right, is the opposite, 250, over the adjacent, which is 33. And in order to get an angle from this, you take the arctangent of both sides.
You mean the inverse tangent or something?
Good. Inverse tangent. That's another word for it.
All right,
So,
all right.
if I do that, if I do the inverse tangent of 250 divided by this, that's going to get me an angle, which is 82.48 degrees, okay? You see that? This will be 82.48
Yes, I see it.
degrees. So that would be 82.48 degrees. We would say north of east. Because you see how this direction is east, and this is like north of it?
All right. I see that, yeah.
You could also say that it's 7.5
Oh, yeah,
degrees
I
east of north. These are both correct.
Yeah, I've seen that. I mean, I've done those.
Cool. Does that make sense?
Yes, it
Nice.
definitely does.
Good job.
Well, it's around 30 seconds now.
Good. Yeah. Good luck with your chess tournament, Ethan. Let me know how it goes. Sick. Okay. Oh, did I give a point to Teacup yet? I don't think I did. Did I give points to Teacup? I think I need to. Fucked up there. Oh. So this is basically how we derived compass readings. Yeah. I mean, compass readings that's how we get the final compass reading, that's for sure. Yes, component vectors. Yeah, exactly. Yeah, if it's this much north and this much whatever, like, it's always the arctangent of whatever that is, and then that figures out what the degrees is. The bearing. I think it's called the bearing. Like, wait, what's the difference between bearing and heading? Actually, I want to know that. Bearing versus heading. Heading is the direction an aircraft is pointing. Bearing is the angle in degrees clockwise from... Okay. Magnetic bearing. Oh, that's kind of cool. I don't know. I've heard them called the same thing sometimes. Magnetic heading, magnetic bearing. Okay, bearing I guess refers to like the angle to the station. Is that what they call it? That's kind of cool. Miracle says, everyone, yeah, I was gonna be original, not do benches. Dude, I almost did benches for my Eagle Scout project. I did, I made a path, is what I did. I made a path that connected like a church to a park. I don't think I built a bench for the park. I think I set that up as like a layup for another Eagle Scout to do. I said like, cool, I built the path. I built a bridge. That's what I did. I built a bridge. I did build a bridge. I built a bridge and I dumped a lot of gravel into like a pathway. And I had to do like a car wash to raise all the money for it. And yeah, and then someone else I think later built the benches for it. Yeah. It's kind of funny how that works. My firearm instructor told me to always carry two compasses, one to check and one to double check when you argue with the first one. Penn Center, that's funny. What do you shoot, Penn Center? I went to the range a couple weeks ago. It was fun. Buddy benches, a place where someone can sit down and then another person can sit and become, well, buddies. Put it in 6 different elementary schools. Dude, what are these buddy benches? Yes, Jamarcus, I'll do your question. Yeah. Here, I just want to see what these buddy benches are, dude. I'm really, really curious. What's a buddy bench? Oh, okay. Is this what a buddy bench is, dude? Dude, why are these benches $800? buddy bench. Bro, I would love to see these things in LA with all like the homeless people sleeping on them. Like, come be my buddy. Hoping to get a 12 gauge. Oh, you're in Canada. Yeah, I don't know what the gun laws are like in Canada. It's probably really hard to get a gun. Here in the U.S., depending on what state you're in, if you're in Texas, dude, they give you one like, you know, when you order your McDonald's fries or something. You know? They're like, yeah, would you like a soda and a 12 gauge? 12 gauge fucking kicks. My shoulder hurts when I shoot 12 gauge. Buddy, dude, I shit you not though. Penn Senator, by the way, my friend was in Idaho, Boise, Idaho, and on the radio he sent me like a clip of it. But they were doing this thing where they said, "Buy a truck, get a gun." I swear it was real. Boise, Idaho. Buy a truck, get a gun. Yeah, here we go. It's the. Oh God.
Got our 10th annual buy a truck, get a gun sale going on. You buy any new truck, used truck, pre-owned SUV, new SUV, get one of these fine dandy things. Just come on down, see me, Cody Mills, not Cody Edwards. And
okay, Cody Mills, dude.
Used truck, any of that, get one of these things. Excuse me, I got some barbecue.
So yeah, dude, Cody Mills Buick down in Idaho. Buy a truck, get a gun. Yeah. It's kind of very interesting, very American. They know their consumer base at least, you know. Cody Mills knows the score, is what we say. Not Cody Edwards. Fuck that son of a gun, Cody Edwards. Oh my god. I'd buy a truck for a free gun. I need both, yeah. Wow, Murgles was, I was going to hire a chef to make gourmet food for the homeless without stopping to think about, yeah, that's a lot to, and also there's a lot of rules in like feeding people. There's a lot of like regulations. There's not many regulations in building benches, which is nice. And yeah, I do like math you can visualize. All right, Jamarcus, let me help you out. You weren't allowed to sit on them to rest, really? Oh, that's terrible. Okay, here, let's get Jamarcus's question. I like this. Looks like it's calculus based or something. You can't drop a gun. Yeah, it has to be concealed enough. Yeah, in California, you have to. It's really weird. You have to. Yeah, the gun has to be not accessible to the driver, so it has to be in like the trunk, and then it can't be loaded. And I think the ammunition has to be stored separately from the gun. So it's like all these rules of like, well, why do I even have this in the car? Because like if shit goes down, like what am I gonna do? Like spend like 5 minutes like unlocking each thing, loading the magazines and whatnot. It's just, I don't know. It's just California has some interesting laws. Sleepy time, night night kittens. Ooh woo woo, ooh woo woo. Is that what you guys say? Ooh woo woo. All right, this is Jamarcus's question. I like this one. What do you do when you're integrating something, but a bunch of things are being multiplied or divided? And what do you do when integrating, but there's another variable? Oh, very good. Very good. These are good questions. Why is Noise being a femboy? Is that a femboy thing now? It used to be like a cute girl thing. Is this where we've like descended? Dude, every day we stray further from God, I swear. Kitten, get on Bed Wars. Daddy's getting angry. Oh God, dude. I don't even want to know what you guys are up to these days. I don't even want to know. Okay. Yeah, so Jamarcus, this is really cool. There's two things here that you're talking about. Okay. So when we like multiply and divide by things, there are different strategies for integrating. Because for instance, Jamarcus, you know how to do this, right? If I do the integral of, let's say, like 3x to the 5th dx, what is this? Good. 3x to the 6 over 6, right? Exactly, right? See how you can just like, you could raise this to the 6. Well, this goes away, right? And then you divide by 6, and then you're done. Okay, awesome. All right. But let's make this a little bit harder. You said like, what happens when they're multiplying, dividing things, right? Okay. So let's say we have, for instance, the integral of, let's say, cosine of x, let's say, how do I want to do this? Yeah, this is cool. This is cool. Let's say this is 3x cosine of x, all right, 3x squared cosine x cubed times the sine of x cubed. I like this. This is a good one. Integrals and derivatives. My life calc flashbacks. Yeah. Okay, yeah, this is good. Yeah, so this looks complicated, right, Jamarcus? Do you know how to do this? There's a cool trick for this one, actually. No clue. Okay. How you do this one? Actually, maybe let me do like a simpler one. Let me do a simpler one real quick. Let's say, for instance, I had the integral of 3x times... No. Yeah, let's do this. Square... maybe I'm trying to like think of like good examples. I'm gonna say this is 2x squared. No. 3x squared square root of x to the third. I can't wait for the kids in my math class to start learning calculus and flip out because they've heard calculus before. Yeah. It's a good one. Okay. So this looks kind of weird, Jamarcus, right? To try and do this, integral. Because it's not a single thing. You could try to turn this into a single thing, right, Jamarcus? You could do, for instance, I could rewrite this as 3x squared times x to the 3/2, right? And then I could combine these two. So that would be 3x to the 7/2. And then you know how to do this integral, right? Yeah, you just raise this and then divide by it. So that becomes what? That's 2/9 times 3, and then it's x to the 9/2, right? Is that what that is? I think it is. Yeah. Okay. So what does that become? That's 2/3. 2/3 x to the 9/2. Okay. The other way to do this, the smarter way, is to do what's called U substitution. Okay. So what I can say here, Jamarcus, is I could say that, okay, I'm going to say let U equal to x cubed. Okay. And then I got to ask myself, what would du be equal to? I didn't like my x. Can I make a U substitution? Dude, that's too good. I like that one. It's 3x squared dx is what we say. Okay. Yeah, don't forget, do that, drop the power. Yep. So if I rearrange this now for dx, right, I'm going to say that, okay, dx is equal to du over 3x squared. All good. All right. So now what I do is I look at my original equation here, right, and I'm going to start replacing some things, okay? So instead of the square root of x cubed, I'm going to call that the square root of u, okay? So this is going to be 3x squared, square root of u. And then instead of dx, I'm going to say it's du over 3x squared. Do you see something special that happens here? What happens with like this and this? Yeah, they cancel out. Good. So this goes away and this goes away, right? So now we're left with the integral of just u to the 1/2 du. Isn't this a much easier, a much nicer integral to do? Yeah, because this just becomes u to the 3/2, and then it's, 2/3, right? Now, the final step you have to do, yeah, if they don't cancel out like that, then you picked the wrong u. So when doing u substitution, you need to make sure that that your final integral only has u's in it. So I'll show you an example of how that doesn't work sometimes. So let's say, for instance, you had the integral of, let's say, the square root of 5x to the 5th plus 2, and then this was like 3x. you wouldn't do this with u substitution, because in this case, right, u would be 5x to the 5th plus 2, and then du would be equal to 25x to the 4th. Also, I thought the dx or du whatever was just a notation, so it means you divide by it or something. Yeah. So when you put this, you can move these things around. You can move them around as much as you want. That's okay. The reason why I write it like this is so that when I plug this in, right, for dx, I see that this is going to cancel out what's there. You're technically not dividing by du. I mean, because du isn't really a thing. It's an operator, or it's like it's the what do they call that? The man, I forget what the thing's called. Not the integrator. The differential. It's called the differential. That's it. Yeah. But yeah, this is a case where u substitution doesn't work, right? Because, right, if I were to substitute this back in, cool, this would go away, but this thing would not cancel out with this. So this is like bad. Yeah. But here, a key thing we needed to do here, Jamarcus, we're not done yet. Once you get to here, you have to remember that your original equation had nothing to do with u's. Like, u was just something you just made up. So you need to plug back in what u is. So in this case, right, u was x to the 3rd. So I get 2/3, and then this is x to the 3rd to the 3/2, which is going to get you 2/3 x to the 9/2, which you should see, right? That is the same answer we got here. Right? Yeah, it's the same thing, yeah. Okay, so let's try to do this one. It's kind of a cool one. Which one, what do you think you're going to pick as your u here? X to the 3rd. Okay. So let's say we called it, let's say we said u was equal to x to the 3rd, okay? That means that my whole expression here, right, would be, okay, cool. This is u, this is, u, and then, well, this is kind of weird, right? This is like u to the 2/3. Do you know how to do this integral? Not really. Yeah, exactly.
That's dope.
Well, it is kind of dope because this actually at least worked, right? du is equal to 3x squared dx. The nice thing is that, like, this at least would still show up. So this actually would have gone away to be du. But, yeah, the issue with this, right, is that I still don't know how to do all these integrals. I don't know how to do the integral of cosine times sine. However, there is like an interesting property here. So, Jamarcus, the strategy when you have this thing, whenever you're trying to do u substitution, is look for something that you could substitute where the derivative of it shows up somewhere else. So you were kind of on the right track because the derivative of x cubed, which is 3x squared, right? That did show up somewhere else. But yeah, it didn't show up here. Cosine of x cubed, yeah, you can use that one. To make the negatives easier, let's say it doesn't matter. You could do either. Either would work, Jamarcus. But let's do sine. Because what is du going to equal now? This is where we have to remember the chain rule. This is why nothing ever leaves you in calculus. Yes, you're right. It would be cosine of x cubed. But remember, right? We got to take the derivative of what's inside. (3x squared). So this is a cool thing. So when, for instance, Jamarcus, if du, like what it is, just already shows up here, you don't even have to do the substituting and whatnot. Okay, so there's still a dx here, right? So see how this whole thing is still there? I can just call all of that du just right away. So I can just say, cool, this is equal to the integral of u, right? Because that's what u is, du. This is a much simpler integral to do, right? What's the integral of u to u? Good. This is u squared over 2, right? And now the last step is that you need to plug back in what u was. So this ends up being sine squared of x to the third all over 2. And you've done it. Pretty cool, yeah? Do you not need the chain rule for integrating? Well, you already did the chain rule. So this was the chain rule. You were just like, you could just do, okay. Yeah. Well, so this is my answer here, Jamarcus. Like the integral of u is just u squared. Now I'm just plugging it in. You don't have to plug in the du or anything. I'm just saying, okay, this is sine of x cubed squared. And then, I know, this is always like sine squared of x squared is what they say. Yeah. We already took care of the chain rule. The chain rule was like this stuff. Yeah. This semester, I'm having what is arguably both my fun and strongest semester. Oh, that's dope. Hardcore geology. Geology's dope. I have a lot of cool friends in geology. Yes, the U sub is the backwards chain rule. It totally is, Penn Center. Yeah, Penn Center's right. It's a cool way to think about it. It's a very cool way. Yeah, so that's when things are multiplying. If you ask during let me save it for another lesson, but I could also show you what's called integration by parts. And that's also cases where you have things that are multiplying. So you could have, for instance, like what's the one they usually do? It's usually like e to the x sine of 4x or something, right? Yeah. This you can do by integration by parts. Or sometimes they do this. Yeah, x to the 5th sine of x. These are other cool strategies that work for multiplying things. When things are dividing, yeah, integration by parts is the backwards product rule. Yeah, that's another very cool one. Yeah, I like that. That's a very cool one. Yeah, this is this is the cool like symmetry between everything, is that like integrals are called antiderivatives, which just means they're backwards derivatives. And there's all these cool properties that you learn about doing derivatives have like analogs, like they have like their reciprocal, whatever, like mirror ones in integration land. And that's like, yeah, integration by parts, use substitution. Yeah, lots of cool stuff there. I like the symmetry, and it's beautiful. It's cool. You also use I think you use the inverse product rule as well for like doing diffie-q. Correct me if I'm wrong. There's like I think there's a diffie-q technique where you're doing like the backwards product rule. Yeah, I don't think... Yeah, he's just learning, like, weird-ass math questions. Like, dude, that Russian math class is hilarious. Chief among geology classes being the paleontology class. That's ultimately what I get into, especially if I... Paleontology... That's cool. Is paleontology, like, the study of bones? Is that what paleontology is? Yeah, those questions are fucking hard, Penn Center, aren't they? Oh, you did figure out the q squared p squared one? Oh, paleontology is fossils. Oh, fossils. That's cool. Fossils are dope. What was the answer to that one, bro? Dude, let me go back to that one. Which one was that? I was mad at that one. Where was it? This one I got. I got this one right. I remember I got this one. Yeah, this one? Oh, we were close? Oh, damn. Yeah, I remember I was trying to do something with, like, completing the square, I think, is what I was doing, right? I was trying to, like, do some stuff like that. P equals 2q. Just sub that into the original. Yeah, that's what I got from this, right? P equals 2q. Wait, and then you sub that into here? Really? How does that work? So what, that's 4q squared minus q squared over Or sorry, plus, sorry. 4q squared minus q squared. Okay. Okay. And then yeah, it looks like secant of z or something. Yeah, like what? Yeah, but wait, how does this work? Oh, okay, wait. So then what is this? Oh, it's just 5q squared over 3q squared. Oh, it's just 5/3. Oh, dude, I'm so dumb. Bro, what? Dude, I had this. I didn't just plug it back in. Oh, yeah. Oh, dude, dude, look what I was doing Penn Center. I was going down a rabbit hole. I think this must have been like late in the stream. This must have been like hour 2 or something. Yeah. At certain points, my brain is just not seeing things anymore. Quadruple digit exponents? Eesh. Yeah. He tried bringing in quadratics. Like, I mean, to be honest, I tried bringing in quadratics as well. I tried like rearranging this whole thing in terms of like difference of squares, but because I saw this, but yeah, it was really just this simple. Yeah, because wait, I got to here, right? Did I ever plug it back in? Bro, what? Dude, why did I not just plug it back in? Dude, this was like the easiest thing ever. Oh, I started doing this or something? I don't know. I think I got tired. It happens. Yeah, the quad exponents was difference of squares. Yeah, 100%. That's what we did here. Yeah, I just actually this wasn't actually was it difference of squares? No, it was actually this. It was actually pretty cool, Penn Center. You just ended up writing like I just defined the lowest number as 2005, and it was like x plus this, x plus this, x plus this, x plus this, and then you found out you could pull out a 3 to the 2x out of everything. And then it was something like this, which isn't like absolutely terrible. Yeah, 4 hours. Yeah, dude, I think the record I've streamed is 2 hours and 30 minutes or 2:45. We did a music stream actually when it was 3 hours once, but music is different. Like I can work on music forever. That's okay. But working on math can get can start doing some things to the brain. Okay. Cool. Let's see. Do I have any other questions? No, everyone's answered the questions. Wait, did Marcus, did I give you a coin for that? I should give you a coin. 1 sec. No, I need to give you a coin. Yeah, my shirt is getting green. Yeah, because I'm wearing a green shirt. It's funny. I'm wearing a green shirt with a green screen. Yeah. I'm invisible. Yeah, Murkish Mark, I can't deal with that's called like jargon. So some fields get really specific about the words that they use to describe like really like specific things. Yeah, it I don't know. I feel like it's kind of like gatekeeping. Like people are like, "Oh, this is a cool kids club." Like only we know about these words. Yeah. Like what's it called? Like the Heliocene or something, or the Apostocene. I don't know. It's all these scene things. They probably do. Yeah, they make like a little cookbook or something. Okay, cool. I think that's all the questions for today. So, thank you everyone for coming to Office Hours. Had a fun time working with you guys. Next stream is going to be Wednesday. I think that'll be the last one I do this week. I don't think I'll stream on Friday because it's the day after Thanksgiving. You should be with your families and stuff. You were trying to prove 10 theorems all mathematicians should know? That's cool. Womp, womp, womp. Yeah, I'm curious what the 10 are. Send me the list of it, Penn Center, if you got the list of the 10. There we go. Epochs in the Cenozoic. Exactly. That's what I'm talking about, Miracle. Yeah, there's just so many. There's so many scenes. Yeah, so anyways, our next stream will be Wednesday. That's going to be an hour later, so that starts at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. What I now do with the kids is I play Fortnite with them. So if you play Fortnite, there's a new season out. Always excited to check it out. So we do that on my other stream, which is actual gaming. So here, let me find out where I put it. Dun, 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 dun. Yeah, I think it's on this one. Let me see. Yeah. Paleocene, Eocene, Oligocene, Pilocene, Pleistocene, Holocene. Yes, there's something special about the Holocene. Isn't there, Mirgo Schmirgle? I think there must be something special about it. Oh, need to start this one streaming. 1 sec. Start streaming. Yeah, try to find it. I'm curious about it. Pen Center. So yeah, if you want to come play Fortnite with us, we're going to do that on actual gaming. If you're in the Twitch, just hang around. It'll take you over to our sister channel. If you're in the Discord, we go down to the recess scene for that. And Turtle wants to speak. Yeah, what's up? Yo, Ramiro, what's going on, dog?
Going on?
What's going on, dude? You enjoying the Thanksgiving break?
Yeah.
Hell yeah, dude. That's dope.
That's dope.
Eating some flautas with the family and stuff. Eating some what, empanadas with the family. What do you guys do for Thanksgiving?
Turkey.
Do you guys do the turkey?
Something different. This year we're actually doing turkey. Last year we did pork.
Ah, okay. Pork is good. I love carnitas. Carnitas is my favorite, dude.
Yeah. The year before that, I think we made tamales.
Ooh, tamales, dude. I love tamales, dude.
Nice.
No, I'm lying. It was tapistes.
Tapistes
are like tamales.
Dude, what are
They're
what are tapistes? What are tapistes?
They're chicken made in like a tamale form. You put plantains, potato inside the foil with chicken and some green sauce, a special green sauce that we make. And it's so good.
It sounds like
you cook it with.
Sounds like taquitos almost, right? It's like tapiste? Oh, I've seen these before. And they're kind of like what are they? They're kind of like circular, right?
Let me see. Show your screen.
Yeah, is my screen not showing? My screen should be showing. Yeah, it should be. Right. Oh, no, there 1 sec. There we go. Now it is.
Yeah, kind of